So, what is momentum? Momentum is the quality of motion on a certain object as it proceeds in the direction. So basically, it describes how hard it is to stop or change the motion of an object. Momentum is just relating mass and velocity and how much it's going to take for you to change the motion of an object. So momentum, or P, is equal to mass times velocity, where P is measured in kilograms times meter per second, because since mass is measured in kilograms and velocity is measured in meters per second, when you multiply these two quantities, you get this, kilograms times meter per second. So impulse is the change in momentum of an object caused by a force acting for a certain time. So that's just basically saying if you had a momentum of 3 first, and then during a time interval you ended up with a momentum of 6, what happened in that time to get you from 3 to 6? And that's where impulse comes into play. So impulse is the force times the change in time, which is equal to the change in momentum, where the J is representative of impulse, and F is force, and the change in time is time. And you can see how force is measured in newtons and time is measured in seconds, so the impulse is newtons per second, times second. So going further, the conservation of momentum comes into play, and it just simply states that momentum of a system must always be maintained, unless there is a non-conservative force. So that's just basically saying whenever you start from A, it has to be the same thing as B, unless something else comes in. So to think of that, you can just say the initial momentum has to equal the final momentum, unless something comes into play. So there are some key words for when you can use momentum. If the problem talks about an explosion or a collision or two objects separate and hit, or it states time and force, then that's a good indicator of when you use momentum. If it just has time by itself, it could be a different category, or if it said force by itself, it could be a different category. But if it mentions time and force, then that's a pretty good indication that it is going to be momentum. So in general, it's just whenever it shows two objects interacting. Okay, so now that we know momentum deals with collision, let's look at the different types of collisions there can be. So the first one is an elastic collision, which is when two objects collide and go in separate directions. In this kind of collisions, kinetic energy is conserved. So the next type of collision is an inelastic collision, which is just when two objects collide and either are deformed or release some type of energy. In this type of collision, kinetic energy is not conserved. The next kind of collision is perfectly inelastic, which is when two objects collide and stick together and then move as one after the collision. So in this type of collision, kinetic energy is not conserved. And if you think about it, it makes sense. If at first two objects were not together and then they came together, there had to be some kind of energy release that made them stick together, some kind of noise that was made or heat that was lost. So the most common approach is to set up a before and after category, and then you calculate the momentum for each object before and after the collision. So let's say, for an example, your system has two objects, a rabbit and a turtle. So you're going to set up a before column and you're going to set up an after column, and you're going to find the momentum for the bunny, then you're going to find the momentum for the turtle before, and then you're going to go to the other category and you're going to find the momentum of the bunny and then find the momentum of the turtle after. So then after you do that, you set the system's momentum of before equal to the momentum of after. So this is just saying, so you're going to add up the momentum of the turtle and the bunny before, and then you're going to set that equal to the momentum of the turtle and the bunny after. The question had asked for find the velocity of the turtle at the end, or what would be the mass of the bunny before. So that's how you would set up this equation and then go from there. So we're going to set up two categories. We're going to do the before first. So we're going to look at car A and car B. So since the cars stick together and momentum is equal mass times velocity, you're just going to add these two masses together. So the mass of the 300 and the mass of the 200, which is equal to 500. That you get that V has to equal 6 meters per second. And that's it. Super easy. graphical problem. It can give you a force times time graph and ask you to solve for momentum or impulse. And so to do that, you're just going to find the area under the curve. And so you can just break the curve up into different shapes. Like you could do triangles, you can do rectangles. And since the graph is a force times graph, the area is going to equal impulse. And it equals impulse because you're multiplying the y values times the x values, and the y values are force and the x values are time. So you're multiplying force times time, which is impulse. So that's how that comes in. So then once you have that value, you'll have to look and see what the question's asking. If the question said something like, if the momentum of the cart was initially 2, what is the final momentum? And then you just add the area under the graph to the 2. You're going to want to write down applicable formulas. So if it's asking how does mass relate to momentum, you'll use P equals mv. If it's asking how time relates to impulse, you'll use impulse equals force times time. So then you're just going to analyze the relationship between the variables. For example, if velocity increases and mass stays the same, then the momentum has to increase. Or if we're looking at impulse, if the force decreases and the time interval stays the same, then the impulse has to decrease. Of the 3 variables, one stays constant, like there isn't a third variable that can come into play and change that relationship. So the most common approach for experimental problems is to set up a before and after, like we talked about earlier in the video. And then you're going to find the missing variable. So you're going to say initial momentum is equal to final momentum, what's missing? And experimental usually comes in because there's going to be more than one variable missing, so you can't exactly do calculations. And this will be like a free response or possibly even a multiple choice. So what do? So you're going to have to try to find one out of those 2 missing variables. And one is usually going to be able to be calculated, and one is just going to be one that you're solving for. So you're going to have to design a way to calculate the missing variable. Often if it's asking like the velocity and a mass, you can balance the object to find the mass, or you can time the object moving for a certain distance to get the velocity. So that's how you're going to solve for experimental momentum problems.